Today we're going to take a look at how to read a comma separated value file and do some processing on it. The problem we're going to work on is we're going to open a file called traffic.csv, which we see here in my text editor, and it has a series of values separated by comma. That's why it's called a comma separated value file. And what we're going to do is we are going to read in each line from this file. We're going to ask Python to break it up into a list, and we're then going to know where everything is by an index in the list and be able to solve the problem. The problem is that we have to write a program that opens the file and outputs the lowest traffic count. Then we have to output the name of all streets whose traffic count is within 2,500, inclusive of the minimum, and we're going to output one street per line on the screen. So to start this, what we're going to do is I'm going to define my main and come down here and put the blocking so that this will only execute if we're not importing it into another program, which we will be doing quite a lot of in CSC 2017. So first thing we're going to do is, and I'm going to write out my thought process. Step one is we need to open a file that ends in .csv. Next thing, what we're going to do is we're going to read the file line by line and break each line into a list such that the list can be used to gain direct access to each data value. Then we're going to store this list into another list, making a two-dimensional Python list. And what we're going to do is we're going to sort the list and number 5 is we're going to print the shortest street name and all streets that are within a 2,500 distance actually I should say traffic count of the shortest of the or the minimum traffic count. And then lastly, we're going to display the results. Okay, so my first function is going to be get the file name. And what I'm going to do is we're going to make sure the file exists before we give them back the file name. So we're going to use a try except to attempt to open whatever file they give us, and then if I'm not able to open it, we're going to generate an error, which we're going to loop back around again and get them to give us another file name. So I'm going to create a little sentinel, otherwise known as a flag, to say when I'm done. So as long as I'm not done. Now here's a little shorthand trick. Since the while needs something that results in true or false, and the variable not done is just true or false, we don't need to compare not done to true, because when true is the same as true, the result is true. So let's just remove the middleman and do the just checking of the variable instead. So now comes our try, and we're going to get a file name. And now that we have this, what we're going to do is we're going to attempt to open it. In read mode, and then we're going to immediately close it because all we're doing is checking to see if it exists. Down here in the accept, and we're going to look for an IO error, and I'm going to assign that to the variable the error, and I'm going to print the error. And then I'm not going to do anything else because it's going to come back up and ask them for a new file name. Now, if I am able to open it, then I'm just going to say not done is false. And when everything is done, I'm just going to return the file name. Now, one thing that I am going to do is I'm going to say if file name is not equal to an empty string, I'm going to do this. If it's an empty string, we're going to return an empty string back here to main, and that's going to be able to end our code. So here in main right now, I'm going to say, whoops, file name is equal to get file name, and while file name is not equal to a empty line, we're going to do something. So right now we have been able to check off part of number 1. Number 2 is we're going to read the file line by line and break each line into a list. So I'm going to call this process file, and I'm going to take in a file name, and what I'm going to do is the following. I'm going to create a two-dimensional array by first creating a Python list and I'm going to call it traffic, and I'm going to make that an empty list. Now, I'm going to say with open file name in read mode as input file. What I'm going to do is I'm going to get a line, that's going to read a single line from the file. Once I have that single line, I'm going to check to make sure that it is not an empty string, because remember, if it is an empty string, that means that I've read everything in the file. And now comes our next line. Our next line is going to be what? Well, we're going to have to break it apart. And how we're going to break it apart is we're going to ask it first to get rid of that pesky \n. And then I'm going to say my data is going to be data in line dot split. Now split is what takes a line and breaks it on a particular character, and we're going to break on the character comma, and each item separated is going to be put into a separate spot of a Python list. Now, before we go any further, let's do a quick little sample so we can see what each thing looks like as it comes in. So I'm going to print the data in the line, and then right after I split it, I'm going to say print the data. And this is just short debugging style, because what we're going to do is when we print, we're going to see the line coming in from the file, and then here we're going to see it as a Python list. So let's give this a shot. And it's going to be called traffic.csv. And this is going to run by. When it finishes, we will scroll back through and we'll be able to see each line as it came in, and then what line 38 does for us. As a side note, for those who are interested in computer science or data science, and actually cyber people too, comma separated files are the most common way of getting mass amounts of data in a uncompressed form. There's several websites out there that have lots of government data. This file here, traffic, I downloaded from a government website that has literally thousands of files of data, all of them comma separated values. And if anybody's interested in the site for to experiment with, let me know and I will provide the site to you. And this is going to go on for quite a while because there's like 100,000 records in here. But we'll just take a quick look. What I read in was this line right here. This is the line from the file, and line 38 split it into a Python list, and notice that each item is going to be at a separate index, and that everything is a string, which is going to cause us to have to do some what do you call it, manipulations. Now, the task requires us to print out the name of the street. The name is going to be in index what, 0, 1, 2. Name's going to be in index 2, and the string form of the distance is going to be in index 0, 1, 2, 3, 4. That string is not going to help us much. We're going to have to convert it to an integer. And in order to solve the task, all we need is what? The name and this particular value in an integer form. So coming back over here, I'm going to get rid of our two debugging lines. And then I'm going to append these in a new Python list that contains only the pieces that I need. So I need the name, Kimball Avenue. That's 0, 1, 2. So that's going to be data of 2. And then I need the integer form of data of 0, 1, 2, 3, 4. And that gets appended to my list. Now we need to know the shortest, correct? We need to know the minimum. And the minimum, I'm going to set it to infinity. Now this is a little Python trick. That if you do float INF, INF is said to be the largest number that your version of Python can handle, and it's going to set this variable minimum to some huge number, which I don't even know. It's astronomical. But what that's going to enable us to do is we're going to check to see if data of 4 is less than the minimum. And the very first time this comes in, we're guaranteed for it to be less than the minimum. And when that happens, we're going to assign the minimum to that new value. And we're going to have to, again, put int around this because string comparison and integer comparison are completely different. When this finishes, the width will automatically close the file, but we now need to return what? Our traffic and the minimum. So we've got our traffic and our minimum. And what we're doing here is we're getting what we need. And now our last thing is to display. Now it says to print the shortest street name and all streets that are within a 2500 traffic count. So one thing that we needed to do here is we need to get this value, or I should say we're going to set this to an empty string, which then we're going to immediately, once we find somebody who is shorter, we're going to assign that to whoever data 2 is. Now comes our display. And we're going to have to return three values: the traffic, which is our two-dimensional list, our minimum amount of a traffic, and the name of the street. Then we have our function called display results, and it's going to need to take in the traffic data, the minimum traffic, and the street name. Which, the reason I did that here instead of the define is so that I could just copy it, paste it, and we now have our function definition. Now, these are just placeholders, so as long as they make sense, I can use them with the same name as as variables in another function because these are just placeholders. So our output is going to be the following. Okay, first thing is we're going to create a variable. Okay, our traffic count maximum to display is going to equal to the minimum traffic coming in plus 2,500. Now, we're going to print. And we're going to print the street name has the lowest traffic count of the value that's coming in as min traffic. Now, I'm going to print and now we're going to go into a for loop. So I'm going to say for I in range. And remember, for loops are the only place that you can use a single letter variable so that we can just control a for loop. So we're going to get how many items are in the list traffic data. And now comes the check. If traffic data and we're going to be on a particular index, and then we got to take a look at the index where we stored our count. Our count is going to be in the index 0, 1. Okay, it's going to be within the index of 1 in this sub list of the list that contains all of the data. Now, what we're going to do at this point is we're going to say if it's less than or equal to traffic okay, we're going to make sure that it's less than that count or less than or equal to that count, and we do not want the name of whoever the shortest street is to appear multiple times. So what we're going to do now is we're going to make sure that it is not the same as the name that is coming in. And if it is, we're going to print which row we're on, which has the name, and then we're going to display its count. And that should be our print. So let's take a look. and see what we get. Oh, a syntax error. What is this syntax error? Well, let's see. I opened, but I don't have a closing curly brace. So let's go ahead and run this. And right now we're going through processing. Now this has taken an awful lot of time. So, did anybody notice that I forgot something? One thing that I did forget was that anytime I'm doing a while loop like this, is I need to, at the end of the loop, ask for the information again. So, let's see what happens. And again, this is taking a little bit too long. So, did anybody catch what I forgot to do? It's the exact same thing. Anytime I am using a while loop that is based on a particular condition at the end of the while loop, I have to read in that data again from the file in order for it not to be in an infinite loop. And notice how quick it came out once we got everything down pat. Now here's a small little issue. The shortest street has 700 vehicles. And here's a list of the streets. Do any of the streets appear more than once? It doesn't look like it. So now we have all of the streets that are within a traffic count of 2,500 of our lowest, which was 700. If there are any questions, please let me know. Thanks for viewing. Bye.